this video, we're going to cover real-world problems that require rational equations in order to solve them. And these specific ones are like distance, rate, time type problems. So first we need to cover the distance relationship formulas. So D in all these formulas represents distance, R is rate, and T is time. Okay, speed is the rate. Those two are the same word, okay? Now, we all know that distance equals rate times time, right? Rate multiplied by time equals the distance that you're going. For example, let's say I'm going 25 miles per hour and I'm going that rate for 3 hours. Then my distance would be 25 times 3, 75 miles that I drove in those 3 hours. Now, these two other equations just come from solving this one. So solving for rate, we would divide by t, so we get rate equals distance divided by time. And to solve for t, we would divide r, so we get time equals distance divided by rate. Okay. Now, many of these kinds of questions that we're going to cover refer to some sort of a current, okay? Now, this is important to note because it's if you're going, let's say for example, downstream, right? Then you are going with the current, right? If you're going down the stream, then you're going with the stream, which means that you're going with the current. And if you're going with the current, then the stream is actually helping you to go faster. And then in that case, you would add the speed that you would normally have if there was no current, which would be your still speed, the speed that you would have in, like, for example, still water, and add the speed of the current to it. Okay? And now if something is impeding your speed, meaning that it's hurting your speed, it's making you go slower, then you would subtract that. So for example, if you were going upstream, right? If you're going upstream, then the current is working against you. And then that means that your real speed would actually be whatever the speed would be for you if there was no current, right? Minus the speed of the current, okay? So let's take a look at our first example, okay? A boat cruises at 30 miles per hour in still water. Okay, so we have a speed here. And again, this speed is for still water speed, so the speed with no current at all. It takes the boat 1.5 times as long to cruise against the current. So notice that it takes 1.5 times as long to cruise against the current. So the time to cruise against the current equals 1.5 times the time that it would be to go with the current, right? And that makes sense because if time is less, right? If there is less time, then that would mean that you got there faster. And if you're spending more time, then that would be that you were slower. So that makes sense. The time to go with the current is multiplied by 1.5 would be the time to go against the current. So it takes more time to go against the current than if you were going with the current. Going with the current is faster. When you're going against the current, then you're going to be slower. So the time against would be whatever the time is with multiplied by 1.5. Okay. Now, it says that you're going 72 miles. Okay, so that's the distance. And they're asking us what is the speed of the current, okay? Now we're gonna go ahead and represent the speed of the current, which is the unknown here, with x, all right? We also don't necessarily know what the time is, but we have a relationship to the time. So we have that the time against equals 1.5 times the time with the current. Now what I would suggest for you guys to do with all of these problems is to set up a table, okay? One of these rows will be all of the information for against the current, and one of these rows will be all of the information with the current, okay? Now you need to figure out what is the distance, what is the rate, and what is the time from the question based on, you know, what is given. So we know that the distance, whether you're going with the current or against the current, that's 72 miles, right? And we talked about that the time to go against the current is 1.5 times the time to go with the current, okay? And the time with the current, of course, would just be time with the current. Now the rate, this is where we have to use this idea over here, okay? If you're going against the current, then that is hurting you, making you go slower. So if you're going against the current, you would subtract the speed of the current. So in still water, we go 30 miles per hour and then we subtract the speed of the current. Now if I'm going with the current is helping me to go faster. So the rate there would be my speed plus the rate of the current, okay? And I'm just using x for the rate of the current because that's just the variable that we set up for it, okay? Now, we do have this equation right here. This is the equation that we're going to use, all right? The time against equals 1.5 times the time with. Now, what is time? Time equals distance divided by rate. So I will take the ratio of the distance over the rate, and that would be for the time against. And then that equals 1.5 times the time with, which would be the ratio of the distance and the rate to go with the current. 30 plus x plus 30 is the same thing. Okay. So now we just have to solve this for x. Once we solve for x, we would get the speed of the current and then we're done. So let's do that. 1.5 times 72, I could bring up my calculator so I can multiply that. Where's my calculator? Oh, it's thinking. Okay, and remember, when you have a numerator, right, and you're multiplying that to a fraction, you only multiply that to the numerator, right? Technically 1.5 is 1.5 over 1, so you multiply 1.5 to the numerator only. So 1.5 times 72 is 108, and then the denominator x plus 30 stays the same. The equation, the fraction on the left also stays the same. Now we have a proportion, one fraction equal to one fraction, so we can cross multiply. 72 times x plus 30 equals 30 minus x times 108. So let's go ahead and do that. 72 times x plus 30 equals 108 times 30 minus x. And I will distribute to both. 72x plus 72 times 30 is 2160. And then 108 times 30 is 3,240. And then 108 times negative x would be negative 108x. All right, awesome. So let's continue from here. We would, let's go ahead and add 108 to bring the x's to the left. And then I'm going to subtract 2160 to bring all of the numbers to the right. So 72 plus 108 would be 180x. And 3240 minus 2160 is 1080. And then we would divide 180 on both sides. 1080 divided by 180, I believe, is 6. Yep. So x equals 6. Now this is a real world problem, so we have to say, what is it? Is it 6 potatoes, 6 tomatoes? And it's the speed of the current, okay? And the speed of the current, the distance is measured in miles, and the time is measured in, doesn't say what the time, hours. So this is 6 miles per hour. That would be the speed of the current. All right. Okay, let's try one more together. We'll try a couple more together. So we have a boat which moves at 36 miles per hour in still water. So again, this is just our still water speed, okay? Travels 28 miles downstream in the same amount of time that it takes to travel 20 miles upstream. Find the speed of the current. So again, we'll go ahead and just make the speed of the current X, and let's make a table to organize our information. I highly suggest to do this because it makes it a lot easier. And one is going upstream, the other one is going downstream, okay? Now again, we're gonna do distance, rate, and time for all of these. So distance is 36 miles per hour is the rate in still water, so we're gonna need that for the rate later on. But as far as the distance goes, it says 28 miles downstream. So you're going 28 miles, that's the distance downstream, and in the same time, so it's the same amount of time, so the time for both of these are equal. So the time for upstream is equal to the time downstream. So the equation here will be the time upstream equals the time downstream. And then the distance going upstream is 20 miles, okay? Now, what is the rate? Well, we're gonna need the rate in still water, and then if we are going upstream, current is working against us, okay? So upstream, current is working against us, so we would do 36 minus X. Downstream, current is working with us, so we would do 36 plus X. Again, this equation here, right, we need to figure out what is the time upstream. Well, time equals distance divided by rate, right? From this equation back here, time is distance over rate. So we will take the ratio distance over rate for upstream, so 20 over 36 minus X, and that would equal the time downstream, which would be 28 over 36 plus X. All right, now we have a proportion, right? So let's go ahead and cross multiply. 20 times 36 plus X equals 28 times 36 minus X. So 20 times 36 is 720. 20 times X would be 20X. 36 times 28 is 1008. And where was I? Oh, 28 times negative X is negative 28X. All right, so now all we have to do is solve for this equation. So I'm gonna go ahead and add 28X on both sides. And I can subtract 720 on both sides. And so on the right hand side, oops, I didn't mean to get rid of this. All right, so now all we have to do is solve this one. So we would add 28X on both sides and subtract 720 on both sides. So we get 48X equals, and let's go ahead and do 1008 minus 720, and that is 288. Divide 48 on both sides. 288 divided by 48 is 6. Oh, what a coincidence. So the rate of the current here is, the speed of the current is also 6 miles per hour. Okay, because this rate is also measured in miles per hour. All right, let's do one more, and then I have a couple for you to try on your own. So we have Jeanette and Michael took a canoeing trip, traveling 6 miles upstream along a river against a 2 mile per hour current. So now they give us the rate of the current. Okay. They then returned downstream to the starting point of their trip, and their entire trip took 4 hours. What was their rate in still water? Okay. So what we're looking for in this case is the rate of still water. We'll call that X. So again, organizing our information is going to be really helpful. So let's go ahead and make a little table here. Okay, so we have the rate going upstream and the stuff going downstream. All right. So we have the distance and the rate and the time. All right. Now let's start filling some of this stuff in. Okay, traveling 6 miles upstream along a river. So upstream we traveled 6 miles against a 2 mile per hour current. So we don't know what the rate of still water is, but if you're going against the current, then that would be subtracting, right? So if you're going upstream, you're going against the current, so that would be X minus 2, whatever the rate of still water is, minus the 2 mile per hour current. Then returned downstream to the starting point of their trip, so they went the same distance, 6 miles. And if their entire trip took 4 hours, what is the rate of still water? Okay, so we can figure out the rate here as well, which is X plus 2, because if you're going downstream, then the current is helping you. And we don't know the time upstream exactly, so we'll call that TU. And we don't know the time downstream, so we'll call that TD. Now what we do know is that the total time together equals 4 hours. So the time going upstream plus the time going downstream equals 4. So let's make our relationship. Time is distance divided by rate. So the time upstream would be 6 over X minus 2. The time downstream would be represented with 6 over X plus 2, and that will add up to equal 4. Okay? Now, we could do this many different ways. I'm going to pick, let's go with let's go with combining these two fractions, okay? And then we can have a proportion and cross multiply. So I'm gonna go ahead and combine these two fractions. Now in order to actually add these, I need a common denominator. This is X minus 2 while this is X plus 2. So I'll need to multiply this fraction by X minus 2, and I'll need to multiply this fraction by X plus 2. And so the numerator here would be 6X plus 12. And then the numerator here would be 6X minus 12, because you have to distribute the 6 to both terms. And the denominator, now that it's the same, would stay the same. X plus 2 times X minus 2. Okay, I could also combine like terms here, so I'll go ahead and do that, which is 12X, and the 12 minus 12 cancels. Now in the denominator, I'll have to multiply that with 4, so I'm just going to go ahead and simplify this right now. We would get X squared minus 4. And that equals 4 over 1. Now we can go ahead and cross multiply. So we have X squared minus 4 times 4 and 1 times 12X. So x squared times 4 would be 4x squared. Negative 4 times 4 is negative 16. And 12x times 1 is 12x. Now this is a quadratic, so I'm going to bring over the 12x to the left-hand side so that I can solve this quadratic. 4x squared minus 12x minus 16 equals 0. All right, let's go ahead and factor out 4 from all of these. We get x squared minus 3x minus 4. And now the coefficient is 1, so to factor this, we would just multiplies to negative 4, negative 4 and 1, and then adds to negative 3, negative 4 and 1. So 4 times x minus 4 times x plus 1. So we have what looks like two solutions, x equals 4 and x equals negative 1. Now, this is a real world problem, right? So what does x represent? Well, x represents the rate of still water. Can you have a negative rate? You can't have a negative speed. You can't go a negative speed. So this one gets tossed out, and our solution is 4. This is our valid solution. So the rate of still water is 4, and I believe this is in miles per hour as well. Yep, miles per hour. So the rate of still water is 4 miles per hour. All right, so hopefully that was helpful. I'm going to go ahead and put up the 2 problems for you to try. Go ahead and pause this video now and try 4 and 5 on your own. Okay, so let's go ahead and work 4 and 5. We have a motorboat can travel 20 miles per hour in still water. If the boat can travel 3 miles downstream on a river and the same time it takes to travel 2 miles upstream, what is the rate of the river's current? Okay, so let's go ahead and organize our information. Makes it a lot easier. We have upstream and we have downstream. Okay, now we need distance, we need rate, and then we need some sort of equation for time, all right? So a motorboat can travel 20 miles per hour in still water. So this is the rate of still water. So the rate go upstream, where you're going against the current, would be 20 minus x. We don't know the rate of the river's current. We don't know, so that's x. And the rate going downstream would be 20 plus x. Okay? Now, if the boat can travel 3 miles downstream, so you went 3 miles downstream, in the same time, so the time to go upstream and the time to go downstream is the same. These two are equal. So our equation here would be time upstream equals time downstream. And the distance that it takes to go upstream is 2 miles, okay? So let's go ahead and write our proportion, right? Time equals distance over rate. Time equals distance over rate. So we have time would be 2 over 20 minus x for upstream, and time would be 3 over 20 plus x for downstream. Okay, now we have one fraction equal to one fraction, and we can cross multiply. So 3 times 20 would be 60. 3 times negative x would be negative 3x. 2 times 20 is 40. 2 times x is 2x. And now we just have to solve. Add 3x on both sides. Subtract 40 on both sides. We get 20 equals 5x. Divide by divide by 5 on both sides. I'm getting ahead of myself. We get x equals 4. So let's just verify, is this miles per hour? Yep, it is. So the rate of the current is 4 miles per hour. All right, let's try 5. Okay, so an express train and a passenger bus leave the same city at the same time for a destination that's 350 miles away. The rate of the train is 20 miles per hour faster than the rate of the bus. Okay. If the train arrives at its destination 2 hours ahead of the bus, find the rate. Okay, so now we don't have upstream and downstream. We have two things working, right? We have the train, and, oh, I think I wrote that in, well, not necessarily the wrong place, but there we go. We have the train, and we have the bus, okay? And again, we need distance, rate, and some relationship with time. So, let's start reading again. The destination is 350 miles away, okay? So that would be the same for the train and the bus. The distance doesn't change, right? The distance for both is 350. The rate of the train is 20 miles per hour faster than the rate of the bus, okay? So the rate of the train, whatever that is, I don't know what that is, right? Rate of the train is 20 miles per hour more. So I'm finding each rate. Let's go ahead and just say the train rate. Let's make that one X. I could have made the bus rate X, but I'm just going with the rate of the train. So the rate of the train is X. And then the bus rate would be the rate of the train is 20 miles per hour faster than the rate of the bus. So the rate of the bus would be whatever the rate of the train is minus 20, because the bus is slower, right? So you would be going at a slower rate. And then it says that the train arrives at the destination 2 hours ahead of the bus. So what is the relationship here, right? If you're arriving 2 hours ahead, that means that you were faster, right? So that is for the train. The train arrives earlier. But arriving earlier with time means less time, right? So that's a little bit tricky. If you arrive 2 hours ahead, that means that the time, if we say the time of the bus is TB, then the time of the train would be TB minus 2. Or you could have done it the other way, done the time for the train is TT, and then done for the bus T plus 2. So you could have done it either way. Okay, that's just how I made sense of the problem myself. All right, so now we have the relationship, right? Here, the time of the train equals TB minus 2, okay? So, time of the train, distance over rate, time of the bus, distance over rate. Let's solve. So time of the train would be 350 over X. Time of the bus would be 350 over X minus 20. And then minus 2 we bring over. Okay? Again, I'm going to go with combining these two, then we can cross multiply. So I need a common denominator. I'm going to multiply by X minus 20 on top and bottom. And we get 350 over X equals 350 minus, actually let me just do this one at a time so I don't mess up. Sometimes if you do too many steps in one, you end up making silly mistakes. So negative 2 times X would be negative 2X, and then negative 2 times negative 20 would be positive 40. Denominator is X minus 20. So now we can combine the numerator, 350 over X equals, the denominator is the same now, and 350 plus 40 would be 390, and of course negative 2X is negative 2X. Now we can cross multiply, and we get, let me scroll up a little bit, we get 350 times X, which is 350X, And then 350 times 20, I believe, is 7,000, but let me verify. 350 times 20 is 7,000. So we got negative 7,000. X times negative 2x would be negative 2x squared. X times 390 is 390x. And this is a quadratic because our highest power is 2, so I'm going to bring everything to the right-hand side so we can solve this one. So I will subtract 350x and add 7,000. So we end up with 0 equals negative 2x squared plus 40x plus 7,000. I believe we can factor out a negative 2 from all of these, so let's go ahead and do that. So we get x squared minus 20x, and then 7,000 divided by negative 2, I believe, is 3,500, but I will just verify. Yep. All right, so now it's where it gets interesting. Multiplies to negative 3,500 and adds to negative 20. Let's go through. Negative 3,500 divided by 2, no. Negative 3,500, let's try skipping some numbers, even though normally I would not suggest that, just because it's so large. So we are going to need to skip some numbers along the way. Let's try 20. Nope, even bigger than that. 3,500, it has to subtract because you're multiplying to a negative, so it has to subtract 20. Divided by, let's try 30. That's not a factor. Let's try 40. Nope. Negative 3,500, I think something smaller, 15. Nope. Let's try 50. Aha! We're in business. So, 0 equals negative 2 times x minus 70 times x plus 50. Oh yeah, 5 times 7 is 35, and then negative 7 plus 5 would be negative 2. So, yep, okay, great. So we get two solutions, x equals 70 and x equals negative 50. Now, what does x represent? This is a real world problem. X represents the train's rate, right? I set up what x is. So, x is the train's rate. You cannot have a negative rate. So the rate of the train is 70. Now let's look at miles per hour. So miles per hour again here. So we are going, the train's rate is 70 miles per hour. And if we look back at the question, they asked us to find each rate. So I need to figure out the rate of the bus as well. Now, the rate of the bus is the rate of the train minus 20. So x minus 20, x is 70, 70 minus 20. The bus rate is 50 miles per hour. So those are both rates. All right, so just for these problems, break down the information, make sure you understand what piece means what. Be careful with going faster, getting there sooner, because if you're getting there sooner, right, that means that you're actually spending less time to get there. So just be careful with that, because it's kind of tricky where if you're thinking about it too fast and not really being careful, you can make a silly mistake. So hopefully that was helpful, and I will see you guys in the next video. Bye!